Acquisition refers to the initial stage of learning something. In classical conditioning, acquisition involves pairing the unconditioned stimulus with the neutral stimulus that will become the conditioned stimulus. The outcome of this pairing can be seen in the graph, which charts the typical results of an effort to condition a dog to salivate in response to a tone. The graph indexes the amount of saliva collected on each experimental trial over a series of trials. During acquisition, the strength of the dog's conditioned response, as measured by the amount of salivation, increases rapidly and then levels off near its maximum. A newly formed stimulus-response bond does not necessarily last indefinitely. If it did, learning would be inflexible. Instead, the right circumstances can produce extinction, the gradual weakening and disappearance of a conditioned response tendency. What leads to extinction in classical conditioning? The consistent presentation of the conditioned stimulus alone, without the unconditioned stimulus, leads to extinction. For example, when an experimenter consistently presents only the tone to a previously conditioned dog, the tone gradually loses its capacity to elicit the response of salivation. Note how the salivation response declines during extinction. Some conditioned responses extinguish quickly, while others are difficult to weaken.
Spontaneous recovery is the reappearance of an extinguished response after a period of non-exposure to the conditioned stimulus. Pavlov observed this phenomenon in some of his pioneering studies. Pavlov fully extinguished a dog's conditioned response of salivation to a tone, and then returned the dog to its home cage for a rest interval, a 24-hour period. During the rest period, the dog was not exposed to the conditioned stimulus. On a subsequent day, the dog was brought back to the experimental chamber for retesting. The tone was sounded, and the salivation response reappeared. Although it had returned, however, the rejuvenated response was weak in comparison to its peak strength. If Pavlov consistently presented the conditioned stimulus by itself again, the response re-extinguished quickly. However, in some of the dogs, the response made still another spontaneous recovery after they had spent another period in their cages. The practical meaning of spontaneous recovery is that even if you manage to rid yourself of an unwanted conditioned response, it may make a surprise reappearance later. Let's check your understanding of the concepts just discussed.
After conditioning has occurred, organisms often show a tendency to respond not only to the exact conditioned stimulus used, but also to other similar stimuli. For example, one of Pavlov's dogs, conditioned to a certain tone, might also have salivated in response to a different tone. Similarly, a young child who receives a painful shot from someone in a white lab coat might become fearful of all people in white lab coats. This is an example of stimulus generalization. Stimulus generalization occurs when an organism that has learned a response to a specific stimulus responds in the same way to new stimuli that are similar to the original stimulus. The likelihood of stimulus generalization depends on the similarity between the new stimulus and the original conditioned stimulus. For example, suppose a dog has been conditioned to salivate in response to a tone of 1200 cycles per second. How might that dog respond to other tones? Click on each of the stimulus tone frequencies to find out. As you can see from this generalization gradient, the more similar new stimuli are to the original conditioned stimulus, the greater the generalization. Conversely, generalization declines as the similarity between the new and original stimuli decreases. John B. Watson, the founder of behaviorism, conducted an influential early study of generalization. Watson and a colleague, Rosalie Rayner, examined the generalization of conditioned fear in an 11-month-old boy known in the annals of psychology as Little Albert. Like many babies, Albert was initially unafraid of a live white rat. Then Watson and Rayner paired the presentation of the rat with a loud, startling sound made by striking a steel bar with a hammer. Albert did show fear in response to the loud noise. After 7 pairings of the rat and the loud noise, the rat was established as a conditioned stimulus eliciting a fear response. 5 days later, Watson and Rayner exposed the youngster to stimuli that resembled the rat in being white and furry. They found that Albert's fear response generalized to a variety of stimuli, including a rabbit, a dog, a fur coat, a Santa Claus mask, and Watson's hair.
Here is little Albert prior to conditioning. As you can see, he is not afraid of the rat. 5 days later, we see little Albert after his conditioning. His fear of the rat is readily apparent. His fear generalized to other furry objects, such as this rabbit. Generalization also occurred to a fur coat and to a Santa Claus mask worn by Watson.
Stimulus discrimination is just the opposite of stimulus generalization. Stimulus discrimination occurs when an organism that has learned a response to a specific stimulus does not respond in the same way to new stimuli that are similar to the original stimulus. For example, a child who receives painful injections only from a certain nurse may learn not to fear other similarly attired medical personnel. What happens to the shape of the generalization gradient as an organism learns to discriminate between the original conditioned stimulus and similar stimuli? Click on the buttons to increase the level of stimulus discrimination and find out. As with generalization, a basic principle governs stimulus discrimination. The less similar new stimuli are to the original conditioned stimulus, the greater the likelihood and ease of discrimination.
We have one more basic process in classical conditioning to consider. Imagine that you were to conduct the following experiment. First, you condition a dog to salivate in response to the sound of a tone by pairing the tone with meat powder. Once the tone is firmly established as a conditioned stimulus, you pair the tone with a new stimulus, say a red light, for 15 trials. What will happen if you now present the red light alone? Will the dog salivate? The answer is yes. Even though the red light has never been paired with the meat powder, it will acquire the capacity to elicit salivation by virtue of being paired with the tone. This is a demonstration of higher-order conditioning, in which a conditioned stimulus functions as if it were an unconditioned stimulus. Higher-order conditioning shows that classical conditioning does not depend on the presence of a genuine, natural, unconditioned stimulus. In higher-order conditioning, new conditioned responses are built on the foundation of already established conditioned responses. Another example is shown here.
Let's review what you've learned. Acquisition refers to the initial stage of learning a conditioned response. In contrast, extinction involves the gradual weakening and disappearance of a conditioned response tendency. Spontaneous recovery is the reappearance of an extinguished response after a period of non-exposure to the conditioned stimulus. Stimulus generalization occurs when an organism that has learned a response to a specific stimulus responds in the same way to new stimuli that are similar to the original stimulus. John B. Watson's experiment with little Albert was an influential early study of generalization. Stimulus discrimination occurs when an organism that has learned a response to a specific stimulus does not respond in the same way to stimuli that are similar to the original stimulus. In higher order conditioning, a conditioned stimulus functions as if it were an unconditioned stimulus.